In this video, we're going to look at simplifying, multiplying, and dividing rational expressions. So first, what is a rational expression? Well, it's just two polynomials divided by each other. So it could look something like 3 over x. It could look more complicated. It could be like x squared plus 4x over 2x cubed minus 3x squared plus 1. So both of these are examples of rational expressions. Really what you're looking for is a variable in the denominator. Okay, whenever you see rational expressions, something you need to think about is domain. The domain is the set of all real numbers that can be plugged in for the variables is one definition. It's all the possible inputs. It's all the places the function is defined. So with the rational function, we're doing division, right? And so we cannot divide by 0. So we need to watch for 0 in the bottom of the fraction. Because that will give us problems. That's where the domain or the values are not part of the domain. So like in this first one, we want to find the domain. To do this, we're going to set the bottom not equal to 0. And that's sometimes weird to say. If you want to just think of, well, set it equal to 0 and the domain is not that number, that's fine too. So here you see a fraction or a rational expression, and you say, well, if I want to find the domain, I got to know where the bottom equals 0. So let's say x plus 9 equals 0. And so now here I'm setting it equal to 0 even. So x is equal to -9. That's the number where the domain or where the bottom will equal to 0. So that's not part of the domain. So the domain would be x cannot equal -9. On this next one, the steps are the same. Find the domain. Well, if I want to find the domain, I have to know when the bottom is not equal to or is equal to 0. So if I set 5y squared plus 10y equal to 0, this is a little more complicated to solve, but I can factor out a 5y, and I'm left with y plus 2. And so y is equal to 0 or y is equal to -2. And let's kind of talk about that. That comes from setting this equal to 0 and then setting this equal to 0. And so your domain is y, and then such that y cannot be -2 or 0. If you want to write that as an interval, you could write, so it's everything from -infinity all the way to infinity, and leave some space here. But that's the lowest number, that's the highest number. But we're going to skip -2. So the way we skip is with the parenthesis and a union sign. And then we're going to go from -2 to 0. And then we're going to skip 0 and go to infinity. So take some time and look at this pattern. This is interval notation. It's worth learning. Notice everything's parentheses because none of those numbers are included. And then to skip a number, use this pattern where you use the number, union sign, and then the number, and then you keep going until the next number you want to skip, or till infinity, or wherever you want to stop. Okay, and then number 3 is setting the bottom equal to 0 to find the domain. Excuse me. So we have 25y squared minus 9 is equal to 0. And this can be solved using square roots. So let's just get y squared by itself. We're going to add 9 and divide by 25. And then take the square root of both sides. And remember, there's a positive and negative answer here because we're squaring the equation. And so we have plus or minus 3 over 5. And so we can write it the same way we did up here with interval notation, or this is called set notation. We'll write it both ways, just so you have that reference. And even set notation here, we could add a little more to this. So you might see like y is an element of all real numbers and then the comma. Or you might just see this listed. And then so the interval notation, it's everything. So from negative infinity all the way to negative 3/5, but we're not going to include negative 3/5. Make sure I get my negative in there. And then we're not going to include 3/5. We're going to go all the way to positive 3/5. And then up to infinity. Okay, and then the domain again, this time still asking for domain, but then also asking for the value of these numbers. So we'll evaluate the function here. So the domain, well, if I set the bottom equal to 0 or not equal to 0, then I get x is equal to, or let's do 2 steps. X squared is equal to 4, so x is equal to plus or minus 2. So these are the numbers that are not included in the domain. And so the domain is x such that x is not equal to plus or minus 2. Okay, and then to find these values, remember with function notation, just plug this number in for x. So r of 3 is equal to 3 times 3 minus 1 over 3 squared minus 4. And you can use a calculator if you want. I'm going to try to do these in my head and hopefully not make a mistake on this video. But so we get 8 on top and then 5 on bottom. And that's reduced. R of negative 1, watch your signs here. Let me move this up a little bit. I don't know if you guys heard that bell, but class is over. You're dismissed. R of negative 1 would be 3 times negative 1 minus 1, and then negative 1 squared. Anytime you square a negative, it becomes a positive. This is a real common place for error, so it's good to look at. Negative 3 minus 1 would be negative 4 on top. And this is 1 minus 4 would be negative 3. So this would be positive 4/3. So keep in mind that this is negative 1. And then R of 2, sorry, I jumped ahead. Keep in mind this is negative 1 squared, and so that becomes positive 1. So it's positive 1 minus 4 gives you negative 3. And R of 2, you shouldn't have to do, right? You could plug it in and you'd get 3 over 2 minus 1 over 2 squared minus 4. But that's 5 over 0. We can't divide by 0. That's not okay. And so this is just undefined. And so and don't use no solution on the empty set. It actually is undefined. There when you plug that in. Okay, let's look at simplifying a couple of these rational functions. So to simplify, the steps are listed there. You're going to factor the top and bottom, so you factor everything. Then you're going to cancel common factors and then write what's left. So factor and then cancel. Okay, so it really depends on how good you are at factoring and how tricky the factoring is. You get a lot of practice with factoring. Here you can't do anything on top, but you can take out a 2 on bottom. And then this is a really good example of a common mistake. So if you look at the top, we have a minus b and then b minus a, or common point of confusion. So those are almost the same, but they're not quite. To make them the same, and take a minute and look at that, make sure you can see that, because a is positive up here but negative down here, and b is positive up here but negative down here. To make them the same, you need to factor out a negative 1 from somewhere. So you could have, if you saw it right away, you could have taken out a negative 2, or you can take out a negative 1 from anywhere. I'm going to take a negative 1 out from the top. So that makes this negative a plus b. And then 2, and then let's just rewrite this. So notice I'm not changing anything. So b minus a is the same as negative a plus b. I'm just changing the order. And now we can see, oh, these are the same. And so on top, we just have -1 or 1. And on bottom, we have 2. One thing to keep in mind that this negative sign it's not really on top. I say on top, but it's not really on bottom. It's just the whole fraction is negative, or the whole expression is negative. So if, -1/2 is the same as -1/2, like that, it's also the same as this. So all these are the same. Sometimes that's confusing for students. Okay, let's look at one more where we're factoring. A lot of factoring here. So let's kind of let's just put some factoring down here. So we need two numbers that multiply to -24 and then add to -10. And so those are -12 and 2. So on top, excuse me, on top we have 4x squared minus 10x. Actually, let's factor this off to the side. Yeah, I'm going to write this down here. Let's do it down here. 4x squared minus 10x minus 6. Use our numbers to rewrite the middle term. Factor out a 4x and a 2. And so that's 4x plus 2, and x minus 3 is my new greatest common factor. Okay, so on top, let's write 4x plus 2. Oh, I forgot my greatest common factor, times x minus 3. And then you can take a greatest common factor out. I should have done that first. Would have made my problem a little easier. But these have a 2 in common, so I can take out a 2 from that first parenthesis and make it 2x plus 1 times x minus 3. Okay, and then on the bottom, let's factor that down here, kind of off to the side. So we need two numbers that multiply to 10. 2 times 5 is 10. Remember, we're looking at the bottom, and add to 11. So those numbers are 10 and 1. So rewrite with those numbers. And then factor by grouping, take out a 2x. Take out a plus 1 if you like to put the 1 there, or just the plus sign. And then you get x plus 5 times 2x plus 1. Okay, so this is what is on the bottom. So x plus 5 times 2x plus 1. And we'll just go ahead and write that over here. Okay, so everything's factored. And then now you reduce. So here with 2x plus 1, so they just cancel. And then you're left with 2 times x minus 3 over x plus 5. This is complete. That's acceptable. A lot of times what we'll do is simplify. So you get 2x minus 6 over x plus 5. And that is reduced. The other thing you can do with these is talk about domain. And so you might say, well, for this function, where does the bottom equal 0? Well, the bottom equals 0 when this is equal to 0. So x is -5 and x is -1/2. So those cannot be included in the function. And so that would be the domain if you were asked for it. X can't be -5 and x cannot be -1/2.